So I'll be talking about quadratic, sorry, coordinate geometry, and the most important thing to know about it is how to know the four cardinal points. For example, the y is the vertical line, the y-axis, and the horizontal line is the x-axis. To this right side, we have a positive x value. To the up, we have the positive y value. To the left, we have the negative x value. Down here, we have the y and the negative y values. Now, the first quadrant, this is the first quadrant, this is the second quadrant, third quadrant, and fourth quadrant. This place is positive, but we have positive y, we have positive x. To this side, we have positive x, negative y. To this side, we have negative x, negative y. And to this side, we have positive y, negative x. So, the next thing I feel you should know is that this side is symmetrical. You can see this side is the same as this side. The only difference is this sign that we have. This side is the same as this side. This side is the same as this side. So that's what they're talking about here. Reflection. I would like to talk about. So the next thing I'll talk about is points. Points on the graph. This is a point, this is a point, this is a point, this is a point. You understand? So this P prime is reflection of P. This here is this P, this is reflection of this. So I would like to use this as an example. Let's say if a Q and R has 2 points and I want to find a distance between Q and R. There's a formula to calculate that, and that's what I want to show here. Here's the formula. QR equals to root of x2 minus x1 all square plus y2 minus y1 all square. So let's say we have point Q to be minus 2. This minus 2 is x and this minus 3 is y. So x and y. X and y. So if I put this into this equation, x2 will be 4, x1 will be minus 1, so you put that here. Y2 will be minus, sorry, not minus, 1.5, and y1 will be minus 3. Put that into the equation here and solve it correctly. You have 7.5, just like we have here. So all you need to do is just know the formula and apply it correctly. Okay, let me move on. So you have to understand the standard linear equation form, and the form is y equals to mx plus b. B is the y-intercept, x is the x-intercept, m is the slope, y is the total value. So you add mx plus b together, it gives you y. So another thing I want to talk about is the slope. If you have 2 points on the graph, you can calculate the slope. And this is the formula: y2 minus y1 over x2 minus x1. So that's the formula. So you can actually apply this formula using this. Now, let's say we have this point Q and point R, and so if we use this formula here, so y1 will be y2 minus y2 will be 1.5, this is it. Y1 will be minus 3, so that's minus 3. X2 will be 4, x1 will be minus 2. When you do this correctly, you have 0.7 for that slope. And there's something else I want to tell you about lines. We can have a parallel line, we can have a perpendicular line. The difference between the two is this: the parallel line have their slope to be equal, and perpendicular line have their slope to be negative reciprocal of each other. Now, if, for example, if I have a line and this is slope, remember I told you this is slope, this is what we talked about here. This is slope, M is the slope. So for this line, 2 is the slope. Let's say here too we have 2. So the two lines will be parallel. But however, they are not parallel because the slope here is 2 and the slope here is minus 1 over 2. And if you look at the two carefully, you understand that this slope is the inverse, is reciprocal, which is 1 over 2. Negative reciprocal, which is negative reciprocal, that makes them perpendicular to each other. So this is a condition for perpendicularity, negative reciprocal of each other, the slope. Now this slope is 2, so this one is minus 1 over 2. So because there's a reciprocal which is 1 over 2 and there's a negative of it, that's why they're perpendicular. So let me just show you how this look on the graph. This parallel. Here we have two lines like this that are not meeting. Parallel lines don't meet. So perpendicular lines, they meet. So this perpendicular. Infinity many solution is when we have two lines on top of each other. This is one line, this is another line. So there's so many solutions. Yeah, but this is what you focus on. Parallel line, perpendicular line. This is just an additional information. I feel I should talk about it. So that's that. We can also actually, if you are given other variables, you can look for the unknown variable. For example, y equals to 0.75x plus b. And let's say you are given this point, minus 2, minus 3. And you are asked to look for the y-intercept, which is b. So if you input this value into this, so for this is minus 2 for x, minus 3 for y. So where you see x, put minus 2, like what you did here, minus 3, put minus 3 and solve it. Now your answer. So the same thing goes for this one. In this case, they want you to look for the x-intercept, but here y is equal to 0, and if the y-intercept is 1.5, then you can solve for your x2. Now here I want to talk about the question. This is a linear equation, power 1. So we can actually plot this on a graph, and I think you need to listen attentively here so that you can apply it to a particular question you were asking me the other time about graph. Your understanding of this will help to solve the question. Now, this is an equation: 4x plus 3y equals to 13, x plus 2y equals to 2. Now, you can rearrange this to have a linear equation form, which is in form of y equals to this first one. If 4x goes to the other side, that will be minus 4x, right? Divide both sides by 3. So that gives you minus 4 over 3x plus 13 over 3. To the other one too, same thing. X go to the other side, it becomes negative minus x plus 2. Divide both sides by 2y, 2, so that you can have your y. So have a minus 1 over 2x plus 1. So that's just the arrangement. Now you can plot these two on this equation, or this, the same thing. This form is the same. Just do your arrangement, the same equation. Now let me teach you that. It's very, very important. Now, if you're supposed to plot those two, plotting of graph now, this is the first equation: 4x plus 3y equals to 13. So cover up one variable. Just let's say you cover up 3x, and just equate 4x equals to 13. That will be 4x equals to 13. You solve for x equals to 13 over 4, which is eventually 3.25. The other one. So since you know the value of x, to know the value of y, you need to cover this 4x. So cover the 4x up and equate 3y equals to 13. you do that, you solve for y, so y equals to 4.33. Now you can plot that on the graph. So x equals to 3.25, y equals to 4.33. So let's check the graph. 3.25, so for this is the first equation. So x, this is 3, so if we go 3.25 will be around here. Well, let's just say 3.3 around here. So a little bit, just tight. Then for the second one, which is for the y, 4.33. So look for on the y-axis 4. This is 4, 4.33. So 4.3 will be around here too. You tie this place, so you join the two stars together. So just draw a straight line, and you have this. Let's check the other one. Now, the reason I'm putting this here is because they are positive. If it's negative, I have to go to the negative part of the graph. So let's check the other one. The other equation is x plus 2y equals to 2. So x cover 2x or 2y, or you have x equals to 2. Then to get your y, cover x up, you have 2y equals to 2. And when you solve for y, you have y equals to y equals to 1. So this is the point, 2, 1. X is 2, y is 1. So let's check that out. So this is second line, x equals to 2. So this 2 for x, you start it, and yeah, y equals to 1. So this is y, and y axis, so this is 1. You start it. So you join the two stars together, gives you this straight line. Now you have to note where they meet, so that will be the solution. 4, minus 1. That's where they meet. So that's how to plot a graph. And it's very, very important for you to actually know this. Very, very important. Now I would like to show you this one is a little bit complex. Not that complex, but the difference between this equation and this equation is that this one has just one solution. That's 4 minus 1. But because we are having equal or greater than, we are having inequalities, it means that we are going to have more than one solution. There's going to be a variation. And by the time you want to plot this one, you might just substitute equals to for this sign. It doesn't matter. You understand? So if we do it that way, or rearrange it the way we should rearrange it, and if you rearrange this first part, that means x goes to the other side, so we have minus x minus 6, then we have minus 3 equals, so divide both sides by minus 3, so we are going to have y equals to 1/3x plus 2. Now you notice that there's a change in this inequality. Why? Because of this negative. I've told you earlier in this story that if you divide an inequality by negative or you multiply by negative, it changes the sign. So that's why you're having the side changing over, flipping over like this. You understand? So that's why. However, it doesn't make it doesn't just for it doesn't change anything, but you have to understand that. In the second one, 2x goes to the other side, that will be minus 2x minus 1, and so we have y equal greater than minus 2x minus 1. Now nothing is changing in the sign because you're not dividing by negative. So that's why this thing is value. However, this does not even matter. I'm just showing you this is the equation form. This is how it needs to be in the equation form. You understand? Now for me to show you how to, the same way you plot the first graph, the same way you do it. All you need to do is just substitute equal to for this value. So I'll continue this in the next video. Yes.